Hello and welcome to the Wildlife Moto channel. So today's video, we're going to be getting stuck into the electrical systems on my 1981 BMW R100 CS. This is one of those jobs that absolutely has to get done before we get properly stuck into the reassembly of this bike. It would be a massive shame to go to all of the hard work of getting everything rebuilt only to neglect the electrics and end up with problems down the line. And for me personally, electrics are one of those areas where I'd say it's not exactly my strong point, but once you take the time to study it and get your head around how things work, on old bikes like this, it's really not that complicated. Electrically, they're pretty straightforward machines. You've just got to make sure you've got a good map in your mind in terms of where everything goes and what does what, so that you can kind of go through a process in terms of replacing the bits that need to be replaced and testing the things that need to be tested and getting everything into good shape. Now, one of the areas that I have been focusing in on is the alternator. It's a Bosch alternator. Now, I've got no reason to believe this thing doesn't work because it had been doing its job perfectly well on the test rides that I did before the strip down. So in general, it's in okay order, but it does need a little bit of attention. So one of the areas you definitely want to take a good look at is the rotor itself. Now, this rotor is actually an electromagnet. These interlocking fingers here are actually north and south pole magnets, and they become magnetized when they're powered up via a couple of brushes that make contact with these two copper slip rings here on the nose of the rotor. Now, those two brushes are sending a DC charge via the regulator, and the regulator therefore can determine how much charge it wants to send to those two copper slip rings, and therefore how strong the magnetic field is going to be around this rotor. And that consequently impacts how much AC power is generated by the actual alternator itself. So that's how the regulator gets to determine how much power is going to be created or generated by the alternator. So in order for it to all do its job, there's a couple of things we want to look at here. So firstly, the condition of those copper slip rings. We want to make sure they're nice and polished so that those brushes have got a really clean surface in which to interact with. The brushes themselves, we'll get onto that in a second, but they definitely need to be looked at too. But other areas on the rotor, just to make sure are all good. It's not a bad idea to make sure that the faces of these magnets are nice and clean to optimize the strength of that magnetic field. But more critically is inside the rotor itself, we've got this tapered little cone here on the back, which actually becomes an interference fit with the nose on the crankshaft itself. So that's where it's going to press onto the crankshaft and ultimately get spun. Now, there is a bolt that goes through this that then kind of bolts it onto the nose of the crankshaft, but we also want to make sure that the surface inside this cone is in really good condition as well. We don't want any scoring, we don't want any pitting, we don't want any dirt in there. We want to make sure that is absolutely optimal in order to ensure the best mechanical fit onto the crank nose. If there's anything going on in here like big scores or pits or rust or corrosion, it may well be worth ditching that rotor and getting a new one, because it's not worth mullering up your crank nose. Also, the other thing to look out for on the back of the rotor, we've got this little ring here, so that's going to press into a seal on the engine. And again, you want to make sure that's nice and smooth. There's no little notches or scores or anything like that that could cause problems with that seal. So effectively, just make sure it's nice and clean. There's no horrible kind of scores or pitting inside that little tapered cone, nothing going on the back of the rotor where it presses into the seal, and get those copper slip rings nice and shiny. If that's all good, then you can probably go ahead and reuse your rotor, which I'm doing. Other things that you want to check, as I said, the brushes themselves. So the brushes actually make contact with those two copper rings and apply the power from the regulator, but they wear out over time. They're just carbon brushes that are soldered onto the little brush holder that sits on the stator cover. So as time goes on, as it gets used, they get worn out and they become shorter and shorter. As you can see, mine here, taking them off the little brush holder, they are pretty short. They've got some meat left on them, but it's well worth taking the opportunity to change them out. It's only about £6 or £7 for a new set of brushes, so well worth doing. If you're alternator is in kind of factory condition, chances are those two brushes will be soldered in place onto the brush holder. So you will need to desolder those. Nice and easy to do that. And the good news is a lot of the replacement brushes actually use crimped on ring terminals, which then just go on to either side of the brush holder bracket. They just kind of bolt down in place. So you don't need to worry about resoldering things. Now, if you want to go one step further on this and go ahead and completely take apart your alternator just to inspect the windings and also to give your stator cover a bit of a clean up and check all the terminals and things like that, you will need to desolder the 3-phase wires that are connected to the stator windings. Inside these units, you've got actually 3 stator windings that are generating power at 120 degree increments. That's where we get our 3 phases of alternating current from. And you've got 3 wires that then come up into a spade block, which then goes off to the rectifier to get turned into a DC current. So in order to take the stator cover off, you will need to desolder those 3-phase wires, and then you can go ahead, undo the spade on the Y terminal, and then you can just take off the entire stator cover. One of the other reasons I wanted to do this was just to double check the sequencing of some of the insulating washers on the Y terminal and on the one of the brush terminals as well, because they absolutely have to be in the right sequence in order to insulate those terminals. And whoever had been in this system before me had, well, they'd almost got it right. It was let's give them an 8 out of 10, but some of the washers weren't stacked in the right order, which obviously wasn't a big deal, but it's not right. And I've gone ahead and done it properly. So we've got 2 insulating washers that go on the backside of the alternator stator cover. Then the bolt goes up through an insulating ring. Then we've got a thicker, smaller washer that then stacks on top on the outside of a stator cover. And then you can go ahead and bolt down the spade terminals. It's important to get that in the right order because you don't want any short circuits or anything like that happening because you haven't properly insulated those terminals up against the stator cover. So anyway, did that, cleaned everything up, resoldered the 3-phase back down. I did also take the opportunity to put a little bit of heat shrink just on each of those wires because the original insulating sleeves had completely disintegrated many years ago probably. So we've got a properly well put together system now, nice and clean, taking the time just to make sure the spade terminals are deoxidized. Use a bit of deoxit spray for that and a little bit of sandpaper just to kind of clean up some of those ring terminals. And it's all back together with new brushes and looking absolutely amazing. I haven't pushed the brushes down yet. We've got 2 little springs that push those brushes down against the 2 copper slip rings. I'll activate those, if you like, when the stator cover is getting installed, because otherwise it can be a bit of a nightmare to have to push the unit over the rotor with those 2 brushes protruding all the way out. Anyway, so that's all sorted. The other thing that I did just quickly was a overhaul of all the wiring associated with the diode board. So the diode board is the component that takes care of converting those 3 alternating waves, those 3 alternating currents from the alternator and turning that into a DC current, which can be used by the bike to power all of its electrical systems as it runs, but also, of course, to recharge the battery as well. So that alternator board is really, really important. All of the wires that connect it to the alternator and connect it off to the starter motor and connect it off to the regulator, all very old, all a little bit crusty and not in particularly great condition. So as a bit of a belt and braces move, I've just gone ahead and changed all of those out. Now you can buy complete kits that pretty much mirror everything from the factory. Really, really easy to install, especially if your diode board like mine is already wired up. It's literally a case of like for like replacing everything and then going ahead and connecting it all to its corresponding part when you go ahead and install it to the bike. So very, very easy, 10-minute job, costs about 50 odd quid or something like that for a new set of wires. Or you could make your own if you really want to, but I did buy mine, so I'm a bit lazy. And that's all now completely ready to go back on the bike when we get to installing this system. The other thing I did was just take a little bit of time to sort out some of the other sub looms, like for example on the indicators. The front indicator loom was a right old rat's nest when I took it off the bike. Somebody had DIY'd this very, very badly, just horrible. So I've gone ahead and remade it using the correct spec wires, the correct color coding, and the correct flag terminals and all that kind of stuff. Really important to use the right color-coded wires when you're rewiring your bike, just because in future, if ever you have problems, you can actually refer back to the original wiring diagram and everything will make sense. If you just use generic black or red or brown wires, you're really not going to know where you are if you get problems, a couple of years down the line. So very much worth using proper spec wires. I get mine from Planet 12 Volt, I think it is. I've got pretty much everything you could ever want. So brilliant. So I did that. The only other thing I did on the back of the bike, mainly because I wanted to replace this rusted old indicator mount bracket. As you can see here, the chrome on this, after 42 years of getting really the worst of it on the back of the bike, it's completely popped. It's pretty much done for. There's not much you can do about that, short of sending it off and getting it re-chromed or powder coated or whatever. But actually for about 30 quid, you can go ahead and get a stainless steel bracket, which will be really easy to look after and mirrors this pattern pretty much identically. Only small challenge in this, once you've taken off the little indicator pods on each side of the bracket, it's just fishing through those wires and making sure you can get them out the other side of that bracket without them getting all kind of bunched up. It takes a little bit of finessing, but actually was a lot easier than I thought it was. So again, another kind of half-hour job to get that system completely replenished, and gives you a good opportunity to kind of check the condition of the bulbs, give those little lenses a bit of a clean up. Only other thing to just be careful of when you're putting everything back together on this is just make sure you don't over torque those screws down on these amber lenses, because you know what it's like, just a little bit of a twist too far and you can go ahead and crack these. So yeah, just be a little bit conservative with the torque on those screws to make sure you don't cause any damage. Thankfully, mine went back together perfectly. So that's about it for the electrical work so far on this bike. And I know that's not an extensive overhaul. There's definitely going to be a part 2 on this where I turn my attention to the main wiring loom and look at that. Now, for the most part, I'm pretty happy with the condition of that, actually. Despite its age, it's in, well, it all works, which is great. And having had a bit of a look at it, it doesn't seem to be overly corroded or overly nasty. So I'm going to hopefully get it back on the bike, because it's quite expensive to change those main looms. I'll give it a bit of a clean up and make sure everything's okay. I'll give it a test off the bike before I reinstall it, and I'll get a video up on that. But I'm hoping that I can go ahead and reuse that. Fingers crossed, otherwise it's going to be another big chunk of change to get that sorted out. Anyway, we are getting very close now to being able to go hang out in the garage and properly get this bike reassembled. Pretty much every component is now done. You might have seen my video that I recently did on the brake calipers, just getting those back together after having the surfaces remachined on those. Obviously the engine's all been done, gearbox, suspension's redone, everything pretty much ready to go. Over the past few weeks, I've spent a huge amount of time and money just ordering bolts and washers and nuts and all the kind of bits and pieces that you generally forget about when you're doing a reassembly of a bike. So I've got a full arsenal of stuff ready to throw at this thing. So fingers crossed we can get properly stuck in and get this thing back on the road very, very soon. Anyway, thank you very much for watching. That's it for now. Until the next one, ride safe.